just say a brief word to open the conversation. From my perspective, when we talk about challenges to environmental and climate sustainability, we're talking about problems that arise because we're not counting everything that creates value. Therefore, we're missing things, and there are deficits in how we responsibly treat the things that matter. We have an initiative that's grown out of work I've been involved in with Citizens Climate Lobby called Resilience Intel. And the short version of what that is an effort to visualize invisible value, the things we haven't been counting, the things we don't know how to value. So I think from the soil ecology perspective, from the Resilience Intel perspective, soil ecology is the measure of the health and resilience and the value of land. And so I think we have 4 really, really smart, detailed presentations by leaders in different aspects of this work. The first is George Boody. He's the Science and Special Projects lead at the Land Stewardship Project. He was executive director there for 23 years. He leads interdisciplinary projects that have to do with measuring the environmental and financial sustainability and health of carbon-rich soil. So, George, I'll leave it to you to explain the rest.
Thanks, George. Thanks, Mindy. It's great to be here tonight. Thanks for inviting me. Appreciate being on the panel with our other panelists and with all of you as participants here. I look forward to the conversation. Just a word about Land Stewardship Project. We're a membership organization. We have 4,300 household members, farm, rural, and urban people, and they want to see agriculture transformed and our food system transformed to be more regenerative. We'll talk a little bit more about that, to address some of the deep racial and social inequities that are involved in our agriculture system today as well. And we do that through a Farm Beginnings training program. We organize farmers and other participants to take part in federal, state, local policy discussions, and we advance soil health and watershed stewardship. And what I want to do here briefly is just talk a little bit about why soil health is the foundation for this work, how animals are crucial to that, animals on the land actually, the experiences of farmers, and some of the impacts if we could scale up, so to speak. Well, but first let's start with the Paris Climate Accords. So they were intended to respond to our climate crisis by keeping the temperature rise less than 2 degrees Celsius by the end of the century compared to pre-industrial times. But in order to do that, we're going to have to reduce greenhouse gas emissions. The Paris Accords were essentially keeping them flat. However, even if all the signatories met their responsibilities, and that is dubious at this point, we still have to reduce greenhouse gas emissions and or store more carbon by 23% just in order to achieve 2 degrees Celsius maximum rise. And so the good news about that is that a growing number of scientists and farmers and groups like ourselves feel that there's a role for agriculture to play to improve soil health. LSP's board believes this is important. Let's see, there, all right. So we have a policy statement on that you can read, and we've also produced this publication. There's a few of them on the table, and if you don't get one, you can download it for free, that details some of the science and also farmer perspectives on this. So I invite you to take a look at that. Next one. Well, in order to be regenerative farming, we need to understand that soil is living, and that we need to take steps to improve its health, especially when it's been degraded over time. And we start with that, next please, with plants. They're nature's solar collectors. And when they take in carbon dioxide, they release liquid carbon, as Christine Jones calls it, from their roots that attract fungi and microorganisms. We'll hear more about that here shortly. And the glue from those soil organisms form aggregates that holds the soil together, and carbon gets stored in those aggregates, along with nutrients and so forth. Tillage breaks those down. In order for those organisms to have a healthy lifestyle, they need a diversity of food. And that comes from diversity of cover on top of the soil and living roots. Next. And here's an example of that. So this is a comparison of perennial wheatgrass in the long roots, the deep volume, and annual weeds throughout the year. And you can see the difference in volume. Perennial wheatgrass is being developed into the plant Kernza by the Forever Green Initiative at the University of Minnesota, along with the Land Institute. So you can see it in a few places, Birchwood Cafe and other places if you eat there. Next, please. Well, what are some approaches for a living, healthy soil that farmers can use, that you can use as gardeners, that can be used on public lands or in golf courses, wherever? One is to minimize soil disturbance, that is to reducing tillage, and also reducing chemical applications that harm soil organisms. Another is maximizing diversity of plants, keeping the soil covered all throughout the year, one way or another, and maximizing living roots, hopefully living roots in the soil throughout the year. Next, we call this in Land Stewardship Project and our colleagues, Greenland Blue Waters, continuous living cover. So if you go west or south, you'll see black soil mostly in the fall and winter. That's not continuous living cover. It should be green or at least brown in the winter. And we also need to reintegrate livestock on the land when possible, especially ruminants. And composting manure is beneficial as well. Next, please. So what's important is how animals are raised. So on your left is continuous grazing, and on the right is managed rotational grazing. So continuous grazing looks kind of like a weedy golf green. There's a few plants sticking up here and there. It's compacted, water runs off. On your right there are the crowleys, and they're well-managed grasslands that have a continuous canopy, deep roots. And cattle are moved around more frequently. It increases higher stocking density that can add profit for farmers, which is important. Next, increases organic matter, captures 3 times the carbon. It improves habitat for grassland birds, and there's better ratios of fatty acids like omega-3 fatty acids that you and I need to eat more of in our Western diet. Next, please. So, Land Stewardship Project has a soil health initiative. We're getting lots of interest from farmers. Conventional farmers, row corn, soybean farmers, those with livestock, organic farmers are meeting together to talk about ways of improving soil health. This is, I want to give you a few examples of farmers. This is the Beyer family. They're down in southeastern Minnesota. They raise milk cows, beef cattle, and hay and pasture, and they transitioned their dairy to organic in 2009, and they've measured an increase in organic matter from 1.7 to 4.4% in 10 years through the system. Next, please. This is Jess and Tammy Berge in western Minnesota. They're grazing their livestock in November and December, when grasses would otherwise have gone dormant, but these turnips and radishes and other things are growing. And this provides a way for farmers to bear the added expense of raising cover crops after their corn and soybean crops by grazing them if there's cattle available. Next, please. This is Jessica and Shane Blair in western Minnesota. This field that is off this way wasn't corn and soybeans. They bought it. Before they bought it, a big rainstorm came, washed a foot of soil across that road onto U.S. Fish and Wildlife Service land. So they've now restored 60 prairie species on it, which they graze from time to time, and they've taken that back to their home farm, where they have multiple species of covers between their row crops. Next, please. And this works on fruits and vegetables as well, and it works in the city. This is a project Land Stewardship Project has with Hope Community Incorporated. on the corners of Franklin and Portland Avenues. And the important thing about this is that not only does it produce food for people to eat, but it's about community and building community. And that's in fact what all of this needs to be about, the community of all of us working together. Next, please. So here's another example, the Brightwoodses in western Minnesota, deep in the heart of corn soybean country, where they brought cattle back and are grazing. Next, please. So in that circle is a trowel. That used to be a gravel road. They filled 8 inches of soil in 10 years. So not only are they filling soil up with carbon, they're building soil. So there's the potential for more carbon in the future. Next, please. So I want to play just a video of Tom Cotter, pardon me, from southern Minnesota, talking about his perspective.
We need to help make the soil strong for our crops to be strong. There's only so much you can do with man-made stuff until you get to a point where you're just spending too much money to help put out a good crop. And the healthier soil, the healthier the plant. And I've always felt that it's kind of like taking my no-till strip-till practices, that's worth 1. My cover crops, that's worth 1. And then my livestock grazing, that's worth 1. Well, 1 plus 1 plus 1 should equal 3, but it actually equals 5, because everything is kind of magnified and gets stronger when it's together. 2 people by themselves really can't do anything, but together they can do a lot. So that makes all the difference in the world.
So this is part of our Soil Builders Network that's about 500 people thus far. 70% are farmers. They're interested in improving soil health. And this video is one in which we're talking to farmers about climate change because we're trying to raise that issue, which is a difficult issue in farm country. You have to do it gently, but we need to make the connections because they certainly understand that weather is changing and impacting them, not only just weather, but a number of other things as well. So next, well, when we can improve carbon and build soil health in the ways that we've been talking about, with more cover on the land, soils start to act like sponges, so they soak up these heavy rainfalls that we're getting. So this is Gabe Brown in North Dakota, a pretty cold area. He's built his organic matter by 3% in 10 years in North Dakota by using multiple species cover and managed grazing. And that means that, next please, that every 1% increase in organic matter holds 25,000 more gallons of water. So that's then available to cover when there's droughts and to keep it from running off. And in western Minnesota, we have a Chippewa project. We call it Chippewa 10% project, where we think that if there can be 10% more living cover in row crops, certain marginal row crop areas, we can meet water quality standards. That's based on monitoring and modeling. We're about 20% of the way toward that 100,000 acres at this point in terms of what farmers have chosen to do. Next, please. So what could happen then in terms of scaling up with regard to carbon greenhouse gases? If we could shift, now this is about beef cattle, so I should just say that all beef cattle start their lives on grass, but most of them, 96% of them in the U.S. anyway, are finished in feedlots, many of them really, really big, with corn principally and some other grains as well. But if we could shift these things, and some of the grass-based livestock is continuously grazed. So we need to shift these. Next, please. If we could shift them to more managed rotational grazing, more diverse cropping systems with cover crops, and maybe longer rotations like organic rotations and so forth, by about 25%. Richard Teague and his group published estimates that basically they took into account soil erosion, which isn't considered in EPA estimates of greenhouse gases from agriculture. And they took into account carbon sequestration, the kind of levels that I've been talking to you about. They felt that a 25% shift of the kinds I just mentioned would reduce U.S. greenhouse gas emissions by 8%. If we could make a 50% shift in regenerative management, that might reduce our greenhouse gas emissions by 28%. At least for a while. At least for a while. Maybe not forever, but for a while. But what that means is that we can't grow as much of protein in these systems when we diversify. So it would require eating less meat. One estimate by Marcia DeLong at Union of Concerned Scientists is that it would be a 10% reduction in servings and about a 25% shift in acreage and management. Well, all of this is one thing, but farmers need markets and they need policy. So what can you do? Join the Land Stewardship Project or other colleague organizations working on these issues. We're working to change federal farm policy, amongst other things, and to get funding for the Forever Green Initiative at the University of Minnesota to start working on these other, to continue working on these other crops. You can invest in local foods and regenerative farmers by buying that food. Sometimes it costs more. That's an investment at this point. Hopefully down the road, I don't know, like I remember buying light bulbs. Or $15 a light bulb or more. They're not that expensive now. I don't know if that'll happen here, but anyway, if you own farmland, you can write some different things into the lease by engaging with your renter or perhaps finding a new one about options. And cutting down on food waste. Food waste is the third largest worldwide contributor to greenhouse gases behind the US and China. So it's a big deal. So I'll end there. A few thoughts. Thanks.
So I feel, the first time I saw George speak about this, I learned a tremendous amount, and I feel that was a very strong introduction to how and why this is such an important issue if we're going to solve some of these problems. Our next speaker is Kassie Brown, Kassie. She's a microbial biologist and executive director of Renaissance Soil, working on soil regeneration and sustaining the vital complex life below the soil that we just started to hear a little bit about. Kassie's talk is called Partnering with Soil Microbes for Plant, Soil, and Climate Health.
Hi everyone, thanks so much for being here. First note, this is my first time ever presenting with a microphone, so let me know how I'm doing. So I'm really happy to be following George because I think that his presentation is the perfect outline for everything else that we're going to be talking about tonight. I see my piece of it as just this one sliver that will hopefully answer a lot of the why questions. Why is soil so important? Why does reducing tillage help anything? And so I'm going to be kind of going through that narrow lens. A little bit about me, like Joe said, I run a nonprofit called Renaissance Soil, and our main work is educating on this topic. So thanks for being here. As you already kind of learned, soil management practices are a huge determining factor in the quality of soil. The piece that I'm focusing on is the microbial element. So the way that we treat soil, whether we treat it as a living soil or we treat it as dirt, it determines the microbial biomass, so the number of organisms that are in the soil. It also has an impact on the diversity, the types of organisms that are in the soil, and it has an impact on the habitat, which I see as the potential for the organisms that can exist down the road. Could you go back one slide? So, just to give you a very stark difference between different management practices, you can have this industrial type agriculture that really treats the ground as dirt, right? It treats it as this thing that we control. We dump the nutrients into it. We have to keep irrigating it. We have to till it all the time. It takes a lot of energy and a lot of work. On the opposite side is this very abundant and life-giving type of agriculture, permaculture, polyculture, all of these different systems that really connect with the soil and treat it as what it is, this living, complex, breathing aggregate of so many different organisms that we are actually a part of. So the management practices that we use to grow our food, they also determine this crazy thing called the soil food web. So this picture is making its way around. It's a really important image. And so I'm kind of going to dive into that. The coolest thing about the soil food web is that it literally starts with the basis of all energy on Earth. So George kind of talked about this a little bit too, but next slide. Primary production, plants, they are the basis of the soil food web and therefore the basis of everything else on Earth, all other life. Plants, as you remember and as you know, use photosynthesis to actually take carbon dioxide out of the atmosphere, break the carbon bonds, and then create long, complex carbon chains that you are very familiar with if you've ever gone on a diet. Sugars, carbs, those are all things that plants are producing using carbon dioxide. So it's these very handy, these very important food resources that plants make for free, just using chlorophyll like it's no big deal. Plants use that energy to grow, and then as George also mentioned, they use that energy to feed soil microbes. So let's dive into that a little bit more. The primary organisms that use root exudates. So that's, when I say root exudates, I mean those sugars that are created out of photosynthesis. Carbon dioxide broken apart, turned into energy/food. Bacteria and fungi are the organisms that are saying thank you to the plants. They're swarming around plant root zones. They're sucking up all of that free energy, all of that really intensive sugar and carbohydrate, protein. All of these organisms exist. We exist because plants know how to use sunlight energy to break apart carbon dioxide, right? So bacteria and fungi are super important. They store carbon in their bodies, and I'll also kind of go into that a little more. Next slide. First, I just want to stop a little bit on the note of fungi, because when you're talking about why tillage is detrimental, why it hurts the soil ecosystem, why disturbance is harmful, when you're talking about why healthy soil helps with water quality and water infiltration, it all comes back to the fungi. So this slide, you can see in the picture, that's a microscopic image of a fungal hypha. Fungi build soil structure. They're kind of the fundamental construction crew of the soil world, and they're really delicate. So tillage, any kind of disturbance, it breaks up the fungi, and it makes them not do as good of a job. So in building soil structure, fungi allow the soil to infiltrate air, which is super critical for all the other organisms. Everything needs oxygen to survive, and the fungi are what's making that possible. They also help infiltrate water. So right now, with climate change being, at least in Minnesota, we're seeing a lot wetter conditions. We need fungally dominant soils to help the water go down deeper. They also liberate nutrients. So I'm trying to kind of set up an outline here for all of the different reasons that fungi are critical when we're talking about climate change. So first of all, water management. Second of all, nutrients. Right now, people are talking about peak phosphorus and what will we do when we run out of phosphorus, when we don't have the fossil fuels to mine the nutrients that we need to grow our plants. All of our synthetic nitrogen is made with fossil fuel energy. So what do we do when we don't have it anymore? What do we do if we want to stop using that, but we still need food? We look to the fungi. They are our partners. They can actually externally digest rocks and minerals and make that into plant-available nutrients. So we don't need to be doing the things we're doing. We can just partner with these organisms. Fungi are also critical in storing carbon. So if we're talking about how to cap emissions, we also want to be talking about how we can pull down what's already in the atmosphere, right? And fungi are kind of the way to do that. In this hypha here, it's almost a solid carbon pipeline. And it's very resilient in the soil. It can last for a long time. Same with glomalin. It's a sticky glue that is pretty much purely carbon. So it's made out of atmospheric carbon that was made by a plant, sent underground, and now it's in this very shelf-stable form that won't degrade, that is back in the soil where the carbon originally came from before we burned it, and also where it's going to remain for a lot of years. If I can just hit that point home a little bit harder, fungi are completely essential for soil-based carbon sequestration. I won't go back into it, but just to put that number into perspective. So remember that 75,000 bacterial species in 1 teaspoon of soil. On Earth, there are 7 billion of us, of humans. We're all one species. So we don't bring very much biological diversity to the table. Compared to 1 teaspoon of healthy soil, where there are 7 billion is the low-end estimate for how many microbes or microorganisms there are. let your head wrap around that for a second. Next slide. And then for another big number, for some perspective, this, I don't even know how to say it, 1 times 10 to the negative 22nd percent, that is how much of Earth's DNA we as humans have been able to catalog. So, and soil is probably the majority of that we don't know anything about. So we are literally scratching the surface of this amazingly complex and important ecosystem that exists right below our feet and that we've really taken for granted with some of our detrimental farming and food growing processes. And then returning to the soil food web, I mentioned how fungi are very sensitive and delicate. They get ripped up through tillage. We destroy them in a lot of the ways you grow food. But then these larger organisms, so further on the soil food web spectrum, you have these shredders and predators, these large organisms. Protozoa and nematodes are the two that I talk about the most. But they're also kind of delicate. They need an intact habitat, just like any of us. We all need a house to live in. We don't want some bulldozer coming around once, twice, 3 times a year, knocking it over so that the soil looks fluffy. You know, we need something that's intact. And so do these organisms. The reason they're important, besides just they're creatures on Earth and they're important, is because their bodies are carbon-based, just like all of us. They're life forms that store carbon. That biomass is really critical, but also they're important because they cycle nutrients. So if you have only bacteria in your soil, which is what happens when you create dirt, your plants aren't getting the nutrition they need. And the plants are then requiring our assistance to have the fertilization every year, right? When you have the full ecosystem intact underground, you have that happening naturally. So you have protozoa and nematodes, these larger organisms. They're cruising through the passageways that the fungi have created. There's plenty of air, there's plenty of water, and they're chomping down bacteria and fungi. As they eat those organisms, they make manure, just like everything else, and they feed the plants. So these ecosystems, as I've mentioned, are basically gone once you've created dirt. All of the practices that we traditionally use in agriculture, tillage, continuous grazing, those things are really reducing this ecosystem, and we're losing a lot of valuable services. Next slide. So when we set up the conditions for the microbial success underground, this is kind of hitting on George's bullet points. We do that by minimizing disturbance, both mechanical and chemical. We maximize living roots, so that's having cover crops, that's planting a diversity of species, even if it's just in a small raised bed. These principles apply for all of us. Responsibly grazing livestock. It's kind of a myth that you have to be vegetarian or vegan if you support the climate, because farmers that are doing it right, the people who are responsibly grazing, moving their cows or whatever around the field, that's inoculating their soil with so much diversity, and it's really helping create this living system. And then keeping the soil covered, with cover crops, either living or dead, using mulch. That's food for microorganisms, and it's also protecting that structure, the houses, the habitat of the organisms that we want to exist. And when we do those things, so that's our human role as I see it when it comes to soil health. That's what we need to be doing. Because then the soil is self-sufficient. It's a very complex system. It came before us. It basically created us. Not basically, it did create us. It's a fact. And so then the soil ecosystem provides these innumerable services: water quality, water infiltration and storage, plant resilience, keeping your plants healthy and from disease, cycling nutrients and making plants more healthy for us to eat and animals. And then the big thing why we're all here, carbon sequestration. These organisms are critical if we want to draw down CO2, and that's how we make it happen. So thanks.
At the risk of oversimplifying, because we're hearing a lot of really, I think, important science coming through in these presentations, we're talking about resources on which all life is based, certainly land-based life. And so part of the work I mentioned earlier, where we're talking about visualizing invisible value and beginning to think about how that becomes investable, what may sound like an oversimplification, but I think is an important insight, is that instead of investing in this foundation of life on land, our industrial scale economy has created incentives for investing in practices that destroy that foundation of life on land. And so there is hidden value at all levels throughout the economy to change that. And I think this is one of the things that we're now beginning to examine, not just in the climate movement and in regenerative farming, but in a much wider context around the world. People are starting to think, can we develop completely different kinds of diversified, sustainable economies that get that right, where there are incentives for that kind of investment in responsible land stewardship. So our next presenter is Julie Ristau. She's the Chief Operating Officer of the Main Street Project. She also founded the Regeneration Partnership and is a leader on permaculture research and sustainable agriculture. And her talk is titled The Triple Bottom Line of Regenerative Agriculture.
Hi everybody, thanks for the introduction. So I'm going to shift gears a little bit. So I think I'm here to tell a story about what we're doing at Main Street Project here in Northfield. It's Minnesota, just a little bit south of here. Most of you know where Northfield is. And what I'm here to talk about is an example, a living example of a project that's trying to integrate these principles and also, through the lens of the triple bottom line, we have created a model that we think is very replicable and easy to scale up. And so I was asked to come and talk about that model and tell you a little bit about how it's working, what some of the challenges are for farmers. And so I've got a series of pictures, and I want to first locate myself. I grew up in southern Minnesota on a diversified farm right on the Iowa-Minnesota border in the middle of the state, which is, I would say, some of the land that's been the most decimated in the last 40 years. I grew up in a 160-acre farm, which was very traditional in that time. We rotated crops, we had animals. There was a community and a lot of people that were working together. The community was 1,500 folks. It was the name of Elmore, Minnesota. When I go back there now, there's nobody left. The people are gone, the soil is decimated. My brother's still there, my mother's still living there. But it's been a journey to see how quickly things can devolve. And it's also been a journey to see how quickly things can revive. And so this is a story of hope. I started working at Main Street Project because I really wanted to be part of a team that was trying to demonstrate that hope. So this is what I'm going to be talking about. This is a model, and I'm not talking about cows, I'm talking about chickens. So this is a poultry-centered regenerative model that was prototyped at Main Street Project over the last 7 years. And this is sort of a picture of what that looks like. We have a stationary coop, a paddock that has perennials in it, and I'll talk a little bit more about it. Paddock meaning it's surrounded by a fence. The chickens rotate through there, and the perennials are a very big part of the story, that also the poultry, but also the people. So we can go to the next slide. And I liked what you said about, what is the general theme? Well, I think everybody that works on this team, and we're all connected in these communities of nonprofits and consumers and everybody that's here, is our hope that humanity can live regeneratively. And we have our chickens here that are reminding us of that. So at the very beginning of this was the knowledge and the understanding that we wanted to try something here that was replicable, but also that at the very heart of it, we understood that we needed a new system. And what we were looking for was a way to demonstrate an ecology and a method that was not extractive, economics that were not extractive in our community. And so the opposite of that is this regenerative way of approaching agriculture, new agricultural practices. And so this was created first with a model, which we'll talk a little bit more, but it's also a systems level project, meaning we're trying to change a system in the Midwest right now and in other parts of the world where we can actually begin to replicate and scale up something that can make a difference. So I wanted to point out it's a model and a system. And, you know, it started first with us looking to nature to create that model. And so this model was founded by one of our visionaries, Reynaldo Hazlet-Marroquin, who is Guatemalan. So interestingly enough, you know, when he was starting to think and we were engaging with our Latino communities in southern Minnesota, what we were discovering was sort of a return or a cellular memory about how animals were raised. So for us, we started with what was really working in other areas of the world. And, you know, the whole idea that chickens like to be in pastures outside was really not adequate to what we knew. So what Ray said was, chickens are really forest animals. They like to be under trees. They like to be protected. They like to be secure. And so the chicken idea was coming and emerging with a body of work at the time, which was about 10 years ago, where we were working deeply with Latino communities in parts of Minnesota. My colleague Neil Ritchie was part of the beginning of that. He's here in the audience. And, you know, really what was coming forth was, you know, how do we create a livelihood that actually is giving life? How can we begin to take some of these folks that are supporting our cheap food industry and, you know, help them create avenues for a more sustainable life. And so the model was sort of contingent on that deep engagement. And one of the things that came up over and over again was food security, healthy food, community food. And the chicken was one of those examples. It was a universal thing that came out of those engaged conversations. And so we returned back to nature to think about this model. And along with that, the other lens, you know, was very clear, which is that what does it really mean to create something that is the triple bottom line? We hear a lot about the triple bottom line in business, in sort of economic speak. We were really looking for what would the model be that actually took each of these pieces and put it on the ground in real life. So the first place we always start is with the social. So our whole model is based on the fact that this has to work for the people who are raising the animals, for the farmers. It has to be profitable, and it has to be equitable. And so we're very consistent in how we think about that reality. So we begin with the social, it has to work for the people first. Economic, you know, is over in the middle here, but I would say our second most interesting, and I'd say lens, is the ecological. So to the point of what we're speaking tonight in all the science, and I'm not the scientist here in the room, but we were really looking for a model that was regenerative, that was getting energy back, that was not extractive, and that could actually help heal soil and water. And so, you know, we have a lot of R&D that we started doing that was actually going to be able to be looked at to say, like, is this working? Is the model that we've put together actually giving back to the soil? Are we increasing the, you know, the quality of the water? And so part of our whole operation has been to actually accumulate research and development. We work some with universities here. So the ecological perspective is very important. On the economic, the middle piece, our starting point is, does it give wealth back to the community? So is this creating community wealth? Are we keeping the dollars in the local, you know, environment? Are we creating something that can be life-giving to the full community? So this triple bottom line is very much our central lens, along with that it's nature-based and has to work for everyone. So we start with that, and then we're also thinking about, again, you know, these basic concepts. We absolutely knew we needed to return animals back to the land. We're very much about, on the ecological level, that we needed to move more towards perennial agriculture and away from monocropping in order for this to be successful. And so we started experimenting with what perennials could we actually put together with our poultry to actually make this sort of synergistic model. So the perennials that are native here to our ecology that we experimented with and are now using are hazelnuts and elderberries. You see a lot of elderberries in the ditches if you drive around southern Minnesota. Hazelnuts are also very native here. And so those two perennial species were connected to the poultry in the paddocks at first to see like how do those work together. And what we found over several years of research is that in connecting those two, it was very synergistic, and that the actual output from having those two connected was that the perennials were producing way above what the norms are, like 2 to 3 times. So we realized like, oh, this is sort of magic. This is a very good combination. And so we began to develop that more, and then we named it Poultry-Centered Regenerative Agriculture. This is an example of the chickens that we also looked at a lot of species of chickens. These are called Freedom Rangers because these chickens are heritage-based breeds, and they actually know how to range. They can get outside and walk around. And believe it or not, a lot of chickens can't do that. And you can tell by the look of stationary coop. The paddock is the full paddock split down the middle, and we rotate the grazing. We have an upper canopy, which are more trees. We have a lower canopy, which tends to be more the hazelnuts, elderberries. We also include annuals in that, like corn and sunflowers. And we have perennial grasses in there. It builds the soil amazingly fast. It's just unbelievable how quickly we can transfer soil with this model. And we've connected it, which you'll see in the next slides, with often acres of perennials that surround this paddock. And so the poultry manure, which is incredibly rich and magic, fertilizes the hazelnuts that are around the paddocks. So again, this replicating the natural systems, here's sort of an aerial of this. We mentioned the perennials, we mentioned the poultry, moving animals back onto the land. Again, we do use some ruminant compost when we can. Our model is based on poultry. We know that a lot of the soil building and carbon sequestration efforts around the country are more focused on cattle and grassland cattle and grazing. This is, a natural component and can be added into that. And so I just wanted to show an aerial view here. You can kind of see the thing from the air, and you can get an idea of what it looks like. Each paddock is about 1.5 acres. So the other thing here that is very important is that we tried to create a model that was easy to enter, required small parcels of land, because our largest community where we tested this and who is part of our team right now are Latino folks in and near Northfield and Faribault. And so a person could acquire 5 acres of land, move forward with that, put up a coop or 2 there, and actually make a pretty good chunk of money during the year. So this is aerial of that. And some of the pictures that show our outputs, we have hazelnuts here, our chickens of course. Sprouts are a big part of our feeding system, which really adds to the vitality and also the nutritional value of the chicken. So this is just sort of a composite of some of the pictures that I thought you'd find interesting. In the middle of our farmer, an example of one of our farmers, Rahe's there. So we can move forward. And, some of the aspects, again, of this, how we think about this model is that it rebuilds fertility in the soil. And, a big part of what we're looking at here is how does perennial agriculture really enable pathways towards improved water quality, which I'm going to talk about in a minute. And then, again, our theme tonight is, of course, the climate. So this is just a close-up of what it's like in the paddock when we're sprouting these grains, and they come up with 2 to 3 days. The chickens go out, they're eating these kind of sprouts. It's adding amazing vitality to the soil. And in doing that, we know that we are sequestering carbon. Part of our, well, I'm going to move to our farm, I think here. This we've already talked about, and others do it more specifically than we do, but I just added this in. Obviously, we have row crops over here, and the water, the carbon leaving the soil over here. We have our perennial agriculture. We do talk a lot about an approach towards perennial agriculture in our work. So this shows the opposite of that. I think we've seen quite a few other slides on that. So we just move forward. Did want to talk about our farm, which is where most of this activity is happening. So over the course of the 8 years that this organization has been working towards this, there were a number of coops that were spread throughout not the region, but throughout this township near Northfield. And in the last year and a half, what we determined is that we needed or wanted to acquire a farm where we could actually be a hub for our farmers. We could have our training consolidated. We could actually be a demonstration place where people come to. So this is a picture of this land in its second stage. This farm is outside of Northfield. It's a great place to come and take a tour. This is in first year of after we acquired it. The farm was owned by a conventional farm family, 5 decades of farming, and I think over 30 years of corn and soybean rotation, mostly corn on that land. So when we acquired it, it was at a real low point. So I wanted to show these slides because one of the things that is just so remarkable, again, about nature is how fast it can heal and how fast it can rejuvenate. And so our R&D farm is an example of that. I can move to the next slide. I want to locate us. This is a region that farm is helping to serve right now. And here, this is how it looked when we purchased it. So here you see bare land. It was remarkable to watch the last crop go off because what became really apparent was that this land had so much water potential and hydrology that had been really stopped because of a practice called tiling. I don't know how many of you folks know about tiling, but a lot of the land in southern Minnesota was artificially drained beginning around 1910. George probably could talk a lot about that as well, but this was an example of a parcel of land that had a lot of tile running through it. And if you look up here this is the north, this is a small ditch tributary that runs directly into the Cannon River. We're in the Cannon River watershed. And so the first thing that we did was just let the land be for several months to see, like, where's the water? Where does the water want to be? And what emerged was this amazing sort of network of small ponds that we then helped to reconstruct. You can see here, right there where there's the dark area, that's one of our wonderful new ponds. That was, when you took the corn off of it, it had a lot of ruts in it. And over time, the pond started sort of shifting and changing shape, and what we were able to do is help it along a little bit. So if you move to the next slide, you can see we already saw this, but over there in the back where it's very dark green is where that pond started emerging. So this is a hill that we started working with. Here you can see that the acreage here are the areas that are obvious, like here. Those are the first hazelnuts that we put into this ground, and so we planted on contour our perennials to start to establish this new ecology there. If we go to the next slide, you can see this is this year. So in 1 year, this is, we built a road out there, but you can start to see the greening. So the first thing we did was put on cover crops last year. We're in our second round of cover crops this year. And what you see here is mulching. So one of the key things with perennials is the addition of mulch or wood chips to the soil to really start to enhance that fertility. And so we've done a lot of composting and mulching of our hazelnuts. This year we planted about 10,000 hazelnuts on this land. And what you see over here to the right is the beginning of the establishment of our coops that we're going to be beginning to build this year. So I wanted to show the difference in 1 year. It's like, wow, you can plant cover crops, things start to move. We've been amazed at the vitality of nature when you let nature start to take its course and you're helping along. And I wanted to show this slide in particular because we're using machinery out there. And to George's point about working with farmers, one of the biggest pieces of this farm was to try to build a number of de-risking strategies for farmers to actually make a transition, because it's really hard to do that. We are locked into policies, as you mentioned, that do not support this kind of agriculture, a financing system that is completely based on monocropping, and so for a farmer to take even 40 acres of land that's marginal and start to move it towards perennial agriculture, because maybe chances are they're not making much money on some of this marginal land, it's next to impossible. Organizations like Land Stewardship have programs that are teaching farmers, which we rely on. We also created a few strategies here that we're now starting to work with. So a couple things there are, what we call perennial financing. Opportunities for people to actually get operating loans that will give them a full 4 or 5 years interest only with very small interest rate. So we have a partner in Shared Capital Cooperative stationed here in Minneapolis to help with that. We also have a land-based partner called Iroquois Valley. They're very farmer-centered, so we're looking to help small beginning farmers acquire land, which is really difficult in many cases. And so those two partners have really stepped up to help help farmers make that transition. We're also looking at providing plant material where we can, so we're looking at perennial nurseries that are more commons-based and working with partners on that. The farm is supposed to be a demonstration and technical assistance and education, so that's some of what we lack. Our skills have really been eroded around biodiversity, diverse farming practices. And so, the biggest piece of that has to do with education. Land Stewardship Project, again, is a great example of offering a lot of that. We're also trying here on this farm to make a place for people to see the demonstration and to actually be in community together. And another aspect of that, I would say, is what I wanted to point out here is there's a lack of equipment, which sounds funny, but a lot of the big equipment just does not serve. So this is a great little thing that we've tried out this year. It's a mulcher. So you see the green tractor, the John Deere, is pulling this little mulcher. It's a row mulcher where you fill the chips into that as an example of a innovative piece of equipment. And the mulching then happens very quickly. It spits it out the side, and so we're trying to make equipment available for farmers and put that to service for others. So this is an example of that mulcher at work, which is cool, and you can see, you can go ahead to that, and this is just another shot of what it looks like now 1 year later. So you see trees in these, this is a line of hazelnuts. The cover crops are in their second iteration. We'll be putting a third cover crop in. So here we go from, having had corn and soybeans on this land just a year ago to this. So what does that mean? What that means is a lot of people are learning about this and also now getting ready to explore the idea of putting poultry in some of these, the area over here to the right. So this is just a quick study of that. You're going to change. We know, one of the things we get asked all the time is, so where are the markets? So the markets are under development, hazelnuts, elderberries, farmers need markets. So I wanted to say, it's not just a small thing here. We're working with partners around the Midwest. And our team, I just wanted to point that out, we have a large team here that I wanted to just show sort of the diversity and some of the folks that are working with us. We have about 15 farmers, our 15 coops that have now been placed. Our work for the coming couple of years is to try to get at least 30 of these coops and more of this marginal land into perennial operation in this area. So we just end by the growing hope. I like the slide that, like, what can you do? Well, the first thing is to have hope. We really believe that these transitions are possible. Obviously, eating local food, eating our chicken is a great thing, and I think Scott's here. Scott, I think, has got a drop site coming up in November. We have a few drop sites here, and we also sell our products at the co-op. I think so much of it is connecting the dots, so what's really hopeful about this conversation is that we're actually connecting these things together, I think, for the first time in a really relevant way. And, helping the farmers to engage in the way that they can and putting the farmer at the center, I think, is really key, and supporting farmers in doing that. So that's the story about our model, and I'm happy to answer any questions. We are part of the Carbon Farming Innovation Network, which is a national network where we're actually measuring and monitoring what the drawdown will be on this land. And that's part of the thing, is how do you measure? It's a big question, and I bet it will come up here tonight. So, thank you.
Thank you, Julie. It's good to see examples of these practices happening in the world, people taking them and making them a reality. I want to just say that before we go to our next speaker, there are index cards available, and if you have questions, if you don't have one, you can request one. I think just put your hand up and someone will find you. Jot your questions down on the cards and they'll bring them up to us for the Q&A afterwards. I wanted to mention, Julie had noted something about water quality. And there is an issue where certain practices upstream cause runoff that goes downstream, and you change the nature of water quality downstream. And on the climate issue, one of the impacts that we care about in relation to that dynamic is on the ocean. So we're talking about soil ecology, but the ecology of life in the ocean is also affected by whether we're doing these things right or not. And that's a big global feedback. So, one of the things I've talked about people with from time to time, and it's useful when you're talking to people who make policy to try to help them understand this. The climate system is a new problem for issues of unsustainability because it's a global system. And so it's not just a local ecosystem, it's a global system, and it connects our physical impacts on the world across the whole world. That connects our physical reality to our metaphysical reality, our moral commitments and obligations and entanglements. And that reminds me that part of the question of what resources are we building? Are we building soil ecology? Are we building sustainable local economies, diversified economies, a healthy, diversified food system? There's also the question of human capital. Do people know that they have these choices? Do they know how to implement these strategies? And so the work we've been hearing about, where people are being educated to be able to take these steps, is critically important. And one very big piece of the policy puzzle that gets solved, and that helps to solve the economic and financial puzzle as well, is that we're starting to move from a world where we thought it's expensive to fix these big problems. If we do it and no one else does it, then we've spent money unwisely, we've wasted money, and we cynically assume others won't do it. And that's been a major obstacle to solutions for a long time. Now we're hearing about a way of doing things where instead of that, getting things right, doing things the right way helps others replicate those good practices more easily. And because the feedbacks are planetary, that comes back to us not just through local benefits, but also through planetary feedbacks. So I think it's great that we're hearing about this local way of engaging to solve this huge problem. Our fourth speaker is Jim Dontje, who is the director of the Johnson Center for Environmental Innovation at Gustavus Adolphus College. He's a focal point for community environmental stewardship efforts and leads the Big Hill Farm Student Garden. And he's also going to be speaking to us tonight about the 2018 Nobel Conference, Actus Davis Adolphus College, Living Soil, A Universe Underfoot. Jim?
I see the podium is recycling. I could just drop stuff right in there, couldn't I? And I could just say an amen and leave, since what we've been getting is pretty good. But I will try and fulfill my duties here and try and wrap us up close to on time. I just want to quickly first respond to a couple things. Since I'm the last person, there's a couple really interesting things going on here. I want to acknowledge our moderator's comment about investment with a short excerpt from one of my favorite poems about farming, which is the Mad Farmer Manifesto by Wendell Berry. And there's a section in the middle that runs like this. Invest in the millennium, like sequoias. Say that your main crop is the forest you did not plant. Say that you will not live to harvest. Say that the leaves are harvested when they have rotted into the soil, when they rotted into mold. Call that prophet. Prophesy such returns. Put your faith in the 2 inches of humus that build under the trees every 1,000 years. Tonight I was building that humus a little bit faster. I also want to acknowledge Julie's comments. One, I grew up about 11 miles from Elmore, so I know exactly what she's talking about. And the other thing is chickens and trees. I lived in Indonesia for 3 years, and I had chickens, and I had this problem. They kept wanting to lay their eggs up in trees. And it wasn't until I just put a nest box on top of our kids' playground that I solved that problem. They went right there first thing, and I could just get the eggs every day. So I want to acknowledge that work and the fun stuff of that. I'm going to be talking about a Nobel conference because the topic fits so well with this and intersects with it. Otherwise, you wouldn't get this commercial message. But I think it's going to be a really fun opportunity to hear speakers talking about different aspects of regenerative agriculture. They may not be using those words, but they're talking about it. Let's keep hopping through the slides here. We tend to, historically, it's thought about soil as geology. These are some roadside cuts that sort of exemplify soil. But, next slide, it's really about life, and keep going clicking, there's a couple more things to show there. We figured this out in some ways because we started finding antibiotics in the soil. And had realized that there are a lot of interesting things in the soil. Which that hunt is still going on, but that leads to our first speaker, who someone was mentioning, and you're gonna have to click through these because I'm gonna have to go pretty fast. Works on something called the Microbiome Project, which is an attempt to do some global measurement of microbial DNA about what's going on. Why is that important? I mean, it's just DNA. Back to those antibiotics. We actually, historically, have only known about a small fraction of what's in the soil because the only thing we can know about is what we can culture. We can take a little tray of something and grow it. Well, it turns out a majority of microbes, all these millions of them, don't culture, so we don't know they're there. This global microbiome project, we go to the next slide, is an attempt to take samples and look at this. And the exciting thing is they've got sort of an initial assay, and with just the initial data, they've realized that they can take a sample of microbial DNA, tell you what kind of ecological system it came from, and probably what kind of an organism it's associated with 85% accuracy. And that's just beginning. So that's Jack Gilbert. He's going to be talking about things. Not really an ag person, but it really connects because of the light. Keep going to the next one. Mycorrhizae, we've heard about them tonight. Just another part of the story. I thought maybe they'd take my thunder and I wouldn't have minded. But all these mycelium growing in the soil, all these fungal connections, next slide, they're talking to each other. They're sending stuff back and forth. And Suzanne Samard is going to talk about that. Now this is causing some of the more doctrinaire scientists to squirm because she's talking about trees talking to each other. And it gets even more, whoa, trees of different species are talking to each other. Whoa. Well, what do we do with that? What kind of language do we have to talk about that? Next slide. There's also this thing going on where Suzanne Simard is convinced that within the same species, trees are helping their offspring. They have networks. And you can say it's just a passive kind of thing, natural selection. You can say it's active. But essentially, she's coined the term mother tree. You've got trees doing things. And this is all going below, so that not chopping up your mycelium is about not chopping up the communication that's going on. Okay, we'll keep hopping here about these speakers. I want to make a historical note. We think we might be doing something new. This is not something we were speaking, but these are, I'm going to show you two books that have been around for a long time. And this person is a big person. He was a part of some of the early USDA development of soil science in the US. But at some point, he took this trip to Asia and said, what's going on with agriculture there? It's been going on a long time, and they're not seeing as much soil degradation. He really looked at organic matter, human waste, the use of organic matter in agriculture, and wrote this book, Farmers of 40 Centuries, as in permanent agriculture. So that was F.H. King, his book, which was published right after his death. His spouse finished the job. But another one that followed on from that is an agricultural testament, Mr. Albert Howard, where he looked at the benefits of compost and really pointed to the fact that it was the fungus that was the benefit. And that book was from 1943. And these books have been around. And if you're really interested in these, they're available. They're out of copy right now, so you can get a PDF of them for free and read about some history. I'll just say a caution about that. A lot of his work was done in a situation in colonial India where he had a lot of cheap labor. And I have some suspicions about that. And also, just for historical fairness, I learned something new today, so let's hop to the next little note here. Howard's first wife actually was credited by Darwin. Darwin forwarded her paper to a scientific society with only her name on it because she had done the work documenting how temperature affects photosynthesis. She passed away. He married her sister. Felt like it was a good fit. She had been more of a humanities person, but she ended up working with the agricultural section of the International Labor Organization, and both were strong advocates for organic agriculture. So I thought that was a piece of the story we didn't want to leave out. So just a little digression. So historical, the point there is this stuff has been going on before, and pay attention to what's there. Now let's get this all out here quick because I'm trying to hurry. This is our author. David Montgomery is a geologist whose specialty is landslides. But he's gotten into writing books. He's written about salmon. He's written about creationism and the flood and how scientists react to that. But he's now written a trilogy of books about the soil, starting with Dirt, the Erosion of Civilizations, The Hidden Half of Nature, which he wrote with his spouse, Anne Blick, about biology, and then finally A Growing Revolution, about this stuff we're talking about, although he tends to call it conservation agriculture. Just a little teaser of the kind of things he will bring out in his historical work on soil. We've heard this story about the Civil War, about what got the South upset was the refusal to let slavery spread into the western states, if you remember your American history. Well, you know why that was? Because the soils in the Southeast were so degraded, they couldn't make any money, and their only market was to sell slaves. That's what they were doing. They were exporting slaves. That's his thesis about what was going on in the South. So he goes through and he really does a good historical review. And let's hop to the next slide, just keep moving here. The other exciting thing is he's going to be our Ristau professor for the spring semester. He will be back. You'll probably see some public presentations by him. He's been traveling around the US and the world, visiting people doing conservation ag, regenerative agriculture, reporting on what they do and trying to synthesize that work together. Okay, keep moving here, we'll keep hopping. I'm just going to skip through this, but I just want to point out how what we do on the land has an effect. We raise the erosion rates, and it's real for here. You guys know this. Let's keep going here. The next one, that's the Mississippi River meeting the St. Croix River. St. Croix River, forested watershed. Mississippi River fed by the Minnesota unforested. There's a story for you right there. And then some notes about where all that sediment's going and increase in sediment rates. Keep going. And where we think there's a lot of argument about what tile drainage is not calling that, not what causing it, but sources of sediment. These are all things that are come up in the conference, but I want to keep going here, which I think is the most relevant thing to what you guys are talking about tonight, is how to get these practices adopted. And in our discussion about who to have speak, we ended up settling on Frank Hugeter. He's actually from Europe, but he's written a lot on environmental practices. He actually has a book on the conservation movement in Nazi Germany. So he's a broad-ranging scholar, but he's really exploring this idea of why we don't do what we know we should do, which ought to be relevant for what we're talking about. And he's going to come, and he's a curious person. He's coming 2 days early because he wants to go out and see some farms in the Midwest. And so he's going to ride in a combine and just get a sense of it. But he's really asking that question of how we get it done. And then the next speaker, we'll keep jumping, is someone I think many of you working this do know about. And this represents something branching out. The Nobel Conference is all about science. We tend to invite PhDs, people with long publication records. This is not Ray. Ray's record is that of a communicator. He has been teaching about conservation, agriculture, soil health for a long time. You've seen, some of you have probably seen his demonstrations. And we thought, given his stature as a communicator and the fact that much of what this is about how to communicate this kind of thing, that we thought we should invite Ray and see what happens with having him mix it up with some of those scientist types. And we're looking forward to that conversation. Someone I remember from my graduate school days now, 20 years ago, was someone who was known as an expert in the field of soil erosion, Ristau. And he has become a major proponent for this idea that we can draw down atmospheric carbon through the soil. Next slide. He's going to have some arguments. We have a speaker from France who was the ambassador for soils in 2015 who says, not so fast. We can't move as fast as you think there are issues. And we're probably going to see some debate. Next slide. One more. I threw this in just to illustrate a key point, and that is the game of carbon drawdown through agriculture is a game of margins. And you know how, there are these stock traders now that are building fiber optic lines so they can trade a slight millisecond faster than anyone else. It's all in the slight difference. That's how they're making their money. Well, soil carbon is about that, because you can see that the difference between GPP, gross primary productivity, and respiration is pretty small. So what we're saying, well, how can we change things with that? How can we make any difference? Well, look over there where our biggest cause of climate change is 6.4 gigatons per year going up from fossil fuels. So over here, we're talking about similar orders of magnitude in the differences in those flows in the soil. All we have to do is tip the balance a little bit, and we're going to make a difference, significant difference. We just have to get the balance right. Keep going here. And again, fill in the slide. I'm trying to keep on time here. Another thing that came out in Julie's talk, and I just realized that there was a piece of this slide that go back right there. Trees are somehow going to be important in this. Reintegration of trees with agriculture is going to be critical. Now we can jump to the next slide. Keep going. I had a chance this summer to travel, and this is examples of trees integrated with agriculture. Those are all farm fields. And sometimes they're trees, sometimes they're not. They're just in there. We're going to have trees in our agriculture if this is going to work. Keep moving here. It's also going to take some time. Again, if you shift those margins, it's going to take some time. That's a picture of Gustavus's old main building next to the result of long-term soil erosion. You can just see the scale of what can happen over time if you can shift the balance one way or the other. And one more slide. The exciting thing, and again, we've heard people allude to this tonight, the exciting thing in regenerative agriculture is we've tended to see saving the planet and feeding ourselves today as in competition. This is an example of terra preta. They found these soils in South America that have been heavily amended with carbon. They're incredibly fertile, unlike the surrounding soils in the jungle, which tend to be very acidic and don't go anywhere productive. This kind of work, storing the carbon in there, has increased soil productivity, growing more food. We can do both. We don't have to live with this competition. And I think we've heard it tonight, but I'll say it again. This is one we can eat our way out of. By what we choose to eat, what the sources of food are, we can make a difference. That's cowpeas and some kind of green and chapatis, unleavened wheat bread, with a little curry dashed in. So the conference is there. We're hoping it will be a place not only to come learn from the speakers, but people talk to each other. Some of these organizations here tonight are going to show up there, and if you aren't, talk to me. We can figure out a way to get you there. There's some registration materials out there. You can do it online, and if you get a group together, you get a discount. So come and have some community. Well, we'd love to see you there. But also, we just love the work you're doing. I'm representing the director of the conference, Lisa Hilke, who is essentially a philosopher of food. And she is just loving this topic this year. You can tell she's so excited because of the connections to growing food. So thank you.
This is the best podium I've ever spoke at. We need composting here. I always say when our trash becomes small and the composting gets bigger, we are moving in the right direction. My name is Paul Thompson. I'm the regional coordinator for Citizens Climate Lobby, which is North Dakota, South Dakota, Iowa, Nebraska, and Minnesota. And we will be having a booth at the Nobel conference. How many people are planning to be at it already? They know they're going down. So if you come and see me and you want to help at our booth, I can give you a word to get a 25% discount. I want to be brief because the big part of the evening and the part that often gets cut out is hearing from the audience. So we really want to hear your questions. So right now there's two things happening. You're writing down your questions for our panelists and for Joe, who needs a card and a pencil. Okay, raise your hand if you do, and then turn them back in, and we'll get them up to Joe so he can start picking your question, because your question is the best one. I've also got $5 gift certificates for the Wedge and Linden Hills, our sponsors for the food. All you have to do is spend $25 and you get $5 off, but who can go to the co-op and spend less than $25? Not me. So we got those. I'm also a proud Gustie. 48 years ago, I graduated from Gustavus, joined the Peace Corps, and that changed my life. And I've been doing this kind of work now for 48 years. But not only is Gustavus doing soil this year, the conference next year, climate changed. So they're going to have another conference. So I'm very proud of my school and what they're doing. And how many of you have graduated from a college, university, or an institution? Raise your hand. There is a huge opportunity right there to make sure that your institution is doing work on divesting from fossil fuels, from working on cutting their carbon, and doing all of the things that we are trying to do here. I was reading a book, or I have read a book, called The Soil Will Save Us by Kristen Olson. I highly recommend it. It's very entertaining and very well written. And when I read it, it's the subtitle is How Scientists, Farmers, Foodies are Healing the Soil to Save the Planet. And I look around the room here and I think, well, how do we, and I actually don't know a lot of you, which is rare, and I know that we're on the right track when we are in places where we're meeting new people. And so tonight, what I want to leave you with is a really short exercise to expand your thinking about where can you go to move this movement to another level. I know for me, I look in the room, do I see a person of color? Are there any people of color in this room? There we are, thank you. Susie, nice to see you. So that's clearly one area that we can improve on when we're looking at food and this issue. The other one would be how many people here are under 25? Raise your hand. Under 30. Okay, so we've got 4. So that would be a whole other area, because believe me, they know what they're doing. And they're the ones who get to really solve this problem. I'll be around a little longer, maybe 30 or 40 years, but who knows. It's really up to us to build an intergenerational movement. So what I'd like you to do right now is turn to the person next to you and spend 30 seconds each way and talk to that person about where's the area that you could open up the conversation that would reach new people. It might be a little bit uncomfortable for you, or you might have to actually go somewhere that you don't normally go. So find a partner. Pick an A and a B. When you've done a better place to do it with 5,000 people at Gustavus on October 2nd and 3rd. Stan has just asked me to tell you that the cups are compostable. And I'm responsible with Stan for about 85% of this event. So give her a hand. Jamie went to the farmer's market at Linden Hills, and she was talking to people from Earth Wisdom Farms, Josh and Laura, and she invited them to come, and this is what he said. Because we make every attempt possible to keep our food accessible to all people, our margins are very tight. At our current pricing, I am on track to make $3.50 an hour this year. Sampling and the time involved in prepping, transporting, attending the event would be essentially cost us the equivalent of 1 day's worth of sales and market. We truly understand and appreciate your intentions. I want to say that again. We do understand your intentions and truly appreciate the opportunity you provided, but this is one of the most important misunderstandings that small farmers and regenerative agriculture people have. We, the farmers, are generally selling the highest quality products at prices that barely support our existence. The most helpful thing you could do at your conference is to suggest that your guests go to their local market this weekend and get to know their farmers, and spend $10 to $20 at 2 different stands. Doesn't have to be ours. To put this in another perspective, if your guests did this every week for the entire marketing season, it would total $34,000. It would pay for the health insurance of 2 farming families, allowing them to quit their off-farm jobs, which they keep for health insurance purposes, and devote more time to their farm, to their soil, their plants, and their animals. The greatest problem in sustainable, ethical, moral, regenerative farming is not lack of public exposure to small farms. It is inaction by those who have already been exposed.
Wow.
Now it's your turn.
So Joe is the global strategy coordinator for the Citizens Climate Lobby. And so global applies in every sense here. It coordinates the building of CCL's citizen engagement groups on 5 continents, leads Citizens Climate Engagement Network, and represents CCL in the Carbon Pricing Leadership Coalition, UNFCCC, that's a United Nations Bureau of Climate Change negotiations, and other United Nations processes. He's a member of the executive board of the UN-linked NGO Committee on Sustainable Development in New York, and he's lead strategist supporting the high-level climate dialogue series, Accelerating Progress, Advancing Innovation. So we are fortunate to have Joe in our midst.
I don't know if I should stand or sit, because I don't think we can all stand up alternately. Are you all comfortable with me sitting with everybody else? So I had a couple of questions I wanted to start out with, but I'm just going to dive into the cards that were submitted because there are a lot of great questions. The first question, which I guess anyone who knows could answer, someone asks, small-scale farmers sometimes complain that they can't do these things because they need expensive, big industrial equipment to produce. What do you say in such a situation? What are the solutions for them to make that shift?
I'm on. The first thing that comes to mind is what we've seen with some of the people working with rotational grazing. I spent time with a farmer who transitioned to rotational grazing, and he was noting the equipment he no longer needed and the time that he had. So it's about looking at the system design. I think that's one example.
Is it fair to say that there's actually, it's a different knowledge base for how you produce?
It's a way off the technological treadmill to focus on soil health, and that treadmill keeps you investing in more and more expensive technology that's made by the largest corporations, and they're making profits when farmers aren't. So we can see what the difference is.
I think an illustrative piece of this is in sustainability work. If you hang around with people a long time, you're going to hear a name, Dontje, who she passed away in around 2000, I think, but she wrote a book before she died called Thinking in Systems, and she just does all these examples of analyzing systems. I was trying to learn it, so I did an exercise last fall with my students looking at Midwestern agriculture. And it's all about feedbacks and what drives things. And what I realized was, in working through that, in the whole system of cash grain crop production, 90% of the players have a benefit in more grain. The farmers have a benefit in more profit, but all the levers that are being pulled are to increase the grain production. So that means technological solutions come first to produce more. But not many people are asking the question of how to make it more profitable for farmers, which might mean buying less equipment, less inputs. So I think that's an avenue to look at. When I've seen organic producers that are making it and doing well, and regenerative farmers, they've asked the question, not how much more can I produce, but how much more profit can I make with less inputs.
That's interesting. So the overall production doesn't have to be more if your inputs are less and your profits are bigger. You can live better.
I would also add that some of the farmers we're working with are re-experiencing what it means to share. So, I mean, what I've experienced in my lifetime is that everybody had to have a full line of equipment, and, you know, there's been a lot of debt associated with that. But there are certain kinds of equipment that you don't have to own it to use it. So in some of the perennial agricultural practices, like I mentioned, the roll mulcher, there are other pieces of equipment like that that aren't necessarily time sensitive, that can be rotated and shared as long as you have an ethos of the commons, meaning that it's there for everyone and we have to take care of it. So there's also management around the commons, but that's part of what we've been trying to move forward is, there used to be threshing teams. Everybody didn't own a thresher, So there are some of those things also re-emerging around some of the new skills and innovation that way.
And the fundamental thing that's different, I think, is this is about technology, because like rotational grazing is impossible without advanced fencing. But it's fundamentally about putting lifting up biology and human management, and decreasing the reliance on technology.
So there were a couple other questions that relate to what are the barriers to adoption. So maybe after this first question, that's an interesting place to go next. What are some of the other barriers besides the cost of inputs and the tendency towards technology?
Culture. So, I mean, there's a powerful narrative. If you went to St. Louis and a Monsanto convention, I mean, it's a rah, rah, rah thing. You are the greatest producers in the world. You're using our technology. That's a powerful narrative that's out there that people, we're humans, we live by story. We're all subject to these in various different ways, and until so part of our organizing is to help people identify, well, who's telling that story that you believe? And then what do you want? So part of it is we have to organize to help people understand the narratives we're subject to, that we don't even know we're subject to until we start talking about it with other people. So that's one thing I would say.
And going off of that too, I think on the cultural note, as consumers living in an urban area, we're always told to buy from your local farmer. You know, we think about regenerative agriculture, we think about food, but the people that have the largest holdings, I think I read a statistic, and correct me if this is wrong, but 50% of corn production in the U.S. goes to ethanol. So we have these narratives that don't quite match up when we're talking about food and sustainable farming, but then how can we also realize that most of our land, you know, a huge percentage of it is being used for fuel that we think of as being sustainable, but if the soil isn't being thought of in those corn growing practices, then that's not a sustainable fuel source, even though it's not maybe a fossil fuel, it's relying on a lot of fossil fuel input. So, on the culture note.
I would add that land costs are significant. There's sort of a rule of thumb in Midwestern agriculture that it takes 3 acres to pay for one, which is to say we're not paying for our land on production. And then you can start asking some system-wide questions about why land costs so much when we can't produce that much. And it has to do with the wider economy and the value of speculation and investment that's going on. I am a part owner, part both in the sense I share it with my brothers and I also in the sense that it's not paid for, of 70 acres of northern Iowa farmland. And I've sat down on the back of the envelope basis and said, could we make it with small grains, which I know would be better for our tenant would grow small grains. Well, the reality is if someone's dependent on the income of the farm, which in this case is my father who we're buying it from, we're funding his retirement, I can't generate the cash flow to cover that land cost, even at a very low interest rate, and the land was purchased before the current rise in farmland. And I can't generate enough income from small grains, just simple bushels per acre times the cost. Can't do it. The land is priced beyond the production. And we need to find out, if we believe that this should happen, all of us, all of you, anyone who's participating in this money economy, has to ask some questions about how they can change that story, how they can create a way for people to farm and not be saddled with the cost of land. So,
I would just also add the operating costs, that again, the cash flow I mentioned with perennial finance, if we're going to move towards more perennials and more perennial agriculture, we need to have perennial financing for those farmers. You know, often, you know, if you plant a hazelnut today, you're not going to get a yield from that for 3 to 4 years if it's a bare root. So it's that, you know, being able to, you know, move through that valley. And so some of it is coupling things and stacking functions like chickens or animals where you can get an instant sort of cash flow in the year, but there are a lot of things that don't work that way. And so I think that's also part of the story. Is we need to, you know, lift that up to say we have the capacity to do that. We're just that, you know, we're just not set up that way. The banks aren't set up that way. I mean, so I just point that out as something interesting to say.
And the other thing I think we should say is we really do need to pay more for food. Now that's tough because some people can't afford to pay more for high quality food. So that's something we have to also address. But those of us who can maybe buy one less iPhone or whatever it is, we need to pay more for food. And that's an investment. We have to look at it as an investment.
I think the American average food budget is 10% of income, which is probably close to the lowest in the world. Just keep that in mind.
This is really interesting because there are also questions about incentives, including one that asked if the Farm Bill could help spur more regenerative farming. And I wanted to mention something at the local level before putting the question to you. George, when you and I first met at Boody, there was discussion there about an idea that local, county level, and state level authorities could change the way land is valued, accounting for soil carbon richness, and that you could couple that higher value with lower taxes on that land. So you give twice the incentive to regenerative farmers to build soil carbon, and that by doing that, without changing any other policies, you might be able to leverage the already existing tendencies of the banking system, the commodities markets, et cetera. Is there room for that kind of policy change? Is there something the Farm Bill can do? Any kind of incentives that you think are useful?
I'm not sure the Farm Bill can address that one, but one of the things that it can do, for example, an important feature of the Farm Bill, which is our nation's food policy, essentially, and it focuses, has an insurance provision called crop insurance, which is something that's pretty practical for farmers. It pays them in times when there's a weather problem or a yield problem, which happens in agriculture. But right now there's no cap, so the larger you get as a farmer, and the more corn and soybeans you grow, the more you can get from the crop insurance program. So there ought to be a cap, which would make more money available for more people. So that's one thing, and it ought to focus on soil health building practices. So that ought to be part of being allowed to get crop insurance that's publicly subsidized, because it is partly publicly subsidized. We subsidize the insurance companies, the administrative costs, and things. So there are things the Farm Bill can do, at least if not that one. But you know, if you think about, just to that other point, Joe, if you think about the balance sheet of a business, the oil companies get to put fossil fuel reserves on their balance sheet, which is one of the things that's built into their value. We don't have soil on a balance sheet. We have the land value, but not the value of soil itself and the degree of function that it has. So I'm not sure how we get that on the balance sheet, but I think that's something worth thinking about.
Yeah, and then I'm just kind of mulling over a lot of different ideas right now, but one thing that we have to remember too is that large-scale farmers in the U.S. are one of the biggest drawers out of welfare from the U.S. government. Like Minnesota's farmers, a lot of them are going out of business this year because of tariffs with China. You know, they're losing $30,000, and that's all that they can afford before they're completely broke. So our system is fundamentally wrong and broken, and so if there isn't ways to make regenerative farming sustainable, forgive my language, but we're pretty much screwed. So the Farm Bill has to figure it out. And I think a lot of that money, though, realistically needs to be changed around so that small farmers are getting better tax breaks, they're getting the same resources that large-scale farmers are getting, and also that large-scale farmers aren't going into so much debt buying the equipment and the fertilizers that they need, which can all be really achieved by focusing on soil health, as we've all kind of been talking about.
And I'll just say there's a couple of sheets on the paper on the table back there about the Farm Bill, which is currently in conference committee between the House and Senate. They may finish it by September, we'll see.
Question of balance sheets and big companies risking bankruptcy because of what sounds like a relatively minor change in their income from international trade. the question of resilience isn't just about ecological resilience, it's about business resilience and economic resilience. And even for large companies, it can be about that. Does building soil carbon richness, soil ecology, make the land more resilient in a way that makes it less vulnerable to failure and therefore more insurable and therefore a better investment for any kind of financing?
Well, I met Grant Wright, who George showed some pictures of in his speech, and their farm is in southwestern Minnesota, is that right? And the year that I was out to their farm, they were kind of laughing because their neighbors have always, a lot of the farmers that practice these regenerative practices, they get a lot of flack from their neighbors. You know, the rural America is a tight community, and the look of weeds, having weeds in the field, and you know, cover crops are thought of as being a weedy thing, and so they're always getting, you know, their neighbors saying, why don't you go clean up? Why don't you do this? Why don't you do that? So this year was one of Minnesota's record rainfall years, as almost every year has been lately. And while all of the neighboring farmers were watching their fields erode, were having to pay so much to have their field roads rebuilt and redone, the Bright Kreutzes are just sitting back like, the water's infiltrating just fine over here, despite having 12 inches an hour. And so those types of anecdotes, where it's really common to hear those sorts of things when you go to sustainable farming conferences. You know, the farmers are just reporting, yeah, we might get laughed at the community diner or whatever, but we're the ones who are actually laughing because we're seeing such immediate and such great results.
And on the flip side, the 2012 drought, there was a retrospective study in Iowa, and corn yields in that year were absolutely correlated with soil organic matter. If you had good soil organic matter, you more likely got a crop than didn't. And it just had to do with the water holding capacity of the soil.
So that's really interesting, because everything that I'm hearing, that we're all hearing, validates what we've heard in international discussions also about this sort of hidden investable opportunity that the entire financial sector of the world could actually begin to discover that this is something they should get involved in more seriously.
It's true, but there's a danger anytime there's big money in agriculture. Let me just put it that way.
And based on David Montgomery, who's going to be at the Nobel conference, I think, can tell us all that it's part of human nature and has been since Roman civilization to degrade any bit of soil health that there is. So we don't, it's something in our consciousness that doesn't allow us to see the value in having it intact. We'd rather degrade it and move on, but because, as Joe was saying, it's a global system, we're kind of run out of land to move on to.
This is probably a place for this comment. I spent 3 years in West Africa around small subsistence farmers, and I spent some time in Indonesia, and I certainly grew up in the Midwest. And one of the tension points I heard it referred to tonight is off-farm employment. Small farmers needing off-farm employment. I actually, as the more I thought about it, I had a kind of a shift. Because of these land cost things, there's an inherent instability in farming. And these peasant farmers I knew in Burkina Faso were actually pretty smart. They all had something else that they did. They were weavers, they were blacksmiths, they had some other business. And maybe we've been pursuing the wrong dream, which is large scale, I can earn my whole living from farming, but rather maybe a greater, more stable system is one in which farming is always a part of something else that's more integrated into other activities. I know that's probably heresy to say. Maybe we should accept the fact that every farmer is not going to earn their entire living from it, because it could be a much more stable system if farmers were integrated in the rest of the economy, that other people had a stake in what the farmer was doing rather than them standing alone.
Can I just say that the outcome of the healthcare debate is going to have a big impact on how functional it's going to be to farm independently, because that's a huge barrier, both access to the healthcare facilities in some cases, but certainly access to reasonable quality insurance that's affordable, that actually pays for things when things go wrong. So it's a big issue.
Is it fair to say that in order to expand the reach of regenerative farming, we need people-friendly communities with diversified economies and a better quality of life so that people don't leave the land?
Probably just add too to that part of what we're trying to move forward is that people can earn some livelihood on smaller parcels of land. So when you think about how hard it is for a beginning farmer to enter, you know, with some of these practices that are more moving towards regenerative and animal-based agriculture, you can make more of a living on 40 acres. You don't need to have the, like in my county, probably similar to, you mentioned, 11 miles away, average size farm is 1,700 right now, where I can come from. So think about that, and how many people are farming that land? One person, maybe, a helper. There's no one left in the communities. So again, going to that, you know, we used to make a living on 160. You know, part of what we're trying to move forward is that you can do more with less land. And there's resilience in that as well.
Yeah, I love that you asked that question too. Just speaking personally, my partner and I have been looking for land to farm, and yeah, I think with young people right now that are interested in taking to buy land to start a regenerative farm, there's like hot spots around the Midwest where there's a vibrant community. You need to have a co-op, you need to have a coffee shop. You know, hashtag entitled millennials. But it's true, but that's how we revive rural America. You know, we find community and people that are thinking the same as we are. We don't want to be in urban centers moving so fast. We want to be on the land, working a farm, having maybe a part-time job on the side. And I think that's really a thing that can happen. But it's just interesting that you asked that, and just thinking about how some people are moving out of the city and back to the country, especially of my generation. But there's particular things that have to happen to make that continue going on.
It's interesting because I asked the question partly because of discussions in the climate policy world about coal towns and other towns that have had an extractive industry that moved on, and they're left, they don't have, let alone a coffee shop with, you know, lattes and all of that, they don't have an old diner either. And so some of those communities are thinking, if we just had just enough so that, you know, Mrs. Smith could sell sandwiches and start a diner, and then we could turn that into something more. Is there a discussion about those kind of incentives for farming communities to build communities?
Well, within the Farm Bill, there are small amounts of money, relatively speaking, to the rest of it, but there are provisions for rural development. There are provisions for local foods. There's to add to the local foods development of rural communities. And I think the other thing we need is arts. The arts help to reform a vital community. So we need all of those things. So there's some investment that's possible through the Farm Bill that should be growing, and commodity supports ramp down, comparatively speaking. So one of the questions that appeared in a couple of different forms, but it was directed at Julie, this particular version of the question, but I think it has a wider relevance too. The question for you, Julie, was, did the percent of carbon at the start get measured? Do you know how it changes each year? And as a follow-on to that, I'll add, does measuring carbon sort of get things started naturally? Does it show someone that maybe I need to do something better or different just because I have the initial understanding that I'm not keeping up?
Well, others can certainly add into this. In our particular situation, we did not measure the starting point of carbon. We're doing that now, so we're 1 year in. We're doing that in part because we have a partnership with a national network that is helping us to do that. And I'm not convinced that there's a lot of different discussions about how well that's done and the different methodologies. My major concern is that some of those costs are expected to be taken on by the farmers, and I have a problem with that. I feel as though, right now we're monitoring several different things, and we have, ours is an R&D farm, but I know my brother, if he was moving this way, would have a hard time collecting evidence, so to speak, on how this is changing. So in our case, we're working with, I mentioned this national organization, which is a soil carbon network. And, there are a lot of expertises in that we can access. But we're also moving forward a larger discussion about who pays those costs and how do we actually keep that going over the years. So I'd like to hear others about that.
Well, I think organic matter is one of those measurements. It's maybe not the best one, but it's certainly a well understood one, relatively speaking, as a test. In the Chippewa River watershed, we use the Haney soil test, which measures, one part of it measures respiration, which is the emitting of carbon dioxide, basically. And so we did that not so much to prove the differences, but to help farmers compare on their own land from when they started something to down the road. And that was of interest when they could do that with the soil scientists, because it's kind of a complicated test and it's hard to understand. But I think there's more work to be done to develop these soil tests that really tell us what we need to know and that move more quickly. So there's another way of looking at soil, which is a different kind of measurement called aggregate stability, and that tells you something about the quality of the soil. Because when the aggregates don't hold together, it blows away or runs off, or it's pulverized or compacted or something that's gone wrong with it. So there's different things that can be done that at least show people the differences.
We are also working on doing biomass counts using light microscopy methods. So actually the soil food web that I was talking about, we have ways to analyze soil. We do this a lot through Renaissance soil. We do it in urban gardens and raised beds. We can get a look at the initial starting soil food web. I'll tell you if it's your lawn or your urban garden, it's probably very much all bacterial at this point. And then we work on some regenerative practices and can look even a couple months later and start to find more fungi coming in and also some of those predators I was talking about, the protozoa and nematodes. And so just looking at the biology and being able to measure it has been a really fun thing, and it also gives people kind of a hard number to keep looking back at.
That's a great example of needing partnerships, too. To one of the barriers is like having you guys come out. I mean, we have Delta Institute and a few universities, but your average farmer, here again, it's like, how do they mediate that? So, know what I think about that. I'm getting economy.
It's interesting. It feels like there's a common theme of cooperation between people and even between sectors, but certainly between plants and organisms under the soil. Kassie, you mentioned urban gardens, and one of the questions was, can carbon sequestration work in urban gardens? Do you have to grow food on land, or is there a way to do this in the city or in other environments?
Yeah, I think that cities, we kind of let ourselves off the hook sometimes and say, okay, I can go to the co-op, but it's those farmers who better shape up. And I mean, farmers have a lot of acres, but did you know that lawn grass is one of the #1 irrigated crops in the United States? So suburban lawns are taking up more water and more resources than farmers producing corn either for ethanol or food. So we have a huge part to play. And I've heard lawn compared to a concrete, like a green concrete, but it doesn't have to be that way. There's definitely biological ways to manage lawn, to manage urban gardens. You don't necessarily have to be growing food. Bee lawns are starting to become a thing. It's bringing in plant diversity, living roots. Grass, for all intents and purposes, is a continuous living cover. So we're part of the way there. Now we just got to integrate livestock, and that can be the microbial livestock. So yes, it can be done.
That's great. That to me shows one of the kind of perverse incentives of the market that we live in, that it sounded to me earlier like farmers sometimes don't go towards cover crops because they have to invest extra in a crop that doesn't necessarily produce a yield for sale, and yet that's what lawn grass is, right? And our whole system is financing that somehow, enough that it happens on that scale. What is the reaction of industrial agriculture to these new options?
Well, I think you have to ask that in a variety of different ways. So farmers that are using industrial techniques, which is most farmers, are getting increasingly interested in soil health because they are seeing that their soils are not functioning. I mean, if you're getting a 1 and 2 inch rain and it's ponding, that's a problem. That says that the soil's not functioning properly. So people are seeing that, and they're seeing, even if they've adopted no-till, which is a way of minimizing tillage, extremely minimizing it. With some slope, people are seeing with these heavy rains that the water runs underneath the residue and still erodes even if in a no-till system. So that's why they've started adopting cover crops, because they've seen some of this on their own lands. So I think rank and file farmers are getting interested in it because they need it, and they're also looking for ways for decreasing expenses down the road, because while cover crops cost initially, eventually they're going to start to reduce input costs, but that's going to take a few years probably. So I think that's one thing. I mean, a number of the companies are talking about soil health. The issue with a company like Cargill, for example, is really they're going to make no money no matter what, because they can buy from somewhere and sell to somewhere else. And it doesn't matter where it is. And they make huge profits on margins, the thinnest of margins. We were talking about that before. So they talk about soil health, and I think they genuinely are interested in it, but there's not a real incentive there for them to incentivize the farmers to do it. So I think there's different issues at different levels.
I've also heard some rumors going around that Monsanto has a whole catalog of biological products ready to be deployed as soon as the turn kind of is made in rural America, which, better for worse, that might be a good thing, but also I think it's just another way to control farmers and have them spend more and more of their money on products. So I think what we really need is farmer education, so that farmers can be evaluating what they actually need and what things actually make their soil healthy versus what is just another product that you need to buy.
I have a question. What do you mean by farmer education?
I think workshops, classes like this one, we work with some small groups of farmers, like in southern Minnesota, where they're learning how to use the microscope to evaluate soil biology. They're learning how to do infiltration tests. I'm sure the Stewardship Project can talk about that a lot. But.
Thank you.
We, for example, had Ray Archuleta in southern Minnesota. We did several workshops. It's also useful, I mean, farmers learn best from each other, so going out on field days where they're hearing other farmers talking about what's working, why this didn't work, what might be going on, what they're going to try next year, and so forth. So farmers learn best from other farmers, but it's also helpful to have somebody like Ray Archuleta come in and sort of lay out a fun picture.
Well, I think we've covered an incredible amount of material, and there's a lot more to talk about, and I could go on for a long time asking more questions, but I think what would be interesting would be if we wrap up and you want to follow up with any of the speakers, find out what resources they have to share, and it sounds like we all have a lot of work to do to try to make this the standard in our country.
So Kassie, on behalf of everybody that's still here, thank you, thank Julie, thank Jim, thank George and Joe for a very stimulating panel discussion on our subject. And would ask everybody that may not have donated to the cause, the baskets are still out for contributions to cover some of the expense of tonight. And, there's still literature on the tables in